All right. Okay. So we're going to let u be x to the 4th plus 2. Again, this is a guess. All right. So here's what we're going to do over here. We're going to find du with respect to x. Du dx then is what? 4x cubed. Okay. Plus 0, right? All right. Now, we have a dx. This now becomes u. This dx would sure be nice if it simplified out. Well, so we're going to treat this like du dx cross multiply kind of deal here. That's totally legal algebra, right? Okay, now, what you'll notice, good, Maggie, did you have a question? No, okay. What you'll notice is the x cubed is over there. The 4 is not, but the 4 is a constant. We can totally work with that. So if we say, oh wait, here's what we have. We have x cubed and dx, which is almost that. Let's get x cubed and dx, and that would just entail what? What do we want to do with that for? Divide it, so that means we could divide it over here. Okay? I don't really want du over 4, that's just weird enough. Okay? So, what I've done so far is I've replaced x cubed and dx by 1/4 du, because they are the same. Okay, what's left? Hold up, Kate. What's left? Cosine of u. Okay, rearrange so it looks a little better. I'm going to put my constant out here. I'm going to put my cosine u here. Du done. I can integrate that. Piece of cake, right? Okay, what's your question, Kate?
Where did the dx go?
The dx got replaced. Dx, x cubed dx is, yes. And then I replaced it. Here it is. 1/4 du is the same as x cubed and dx. Cosine u is this. There we go. Rearranged.
So why the 1/4 du? So you can.
I have to substitute the same things. I can work with a constant, but if that wasn't there, we'd be in a world of hurt because we're like, what? Okay. All right, you ready to integrate? Here we go. 1/4 is just hanging on. What's the antiderivative cosine? Negative sign. Are you sure about that? Just sign, right? Isn't the derivative of sine cosine? Okay. And don't forget your c. All right, finish it up by putting the u back in. Sine of u is x to the 4th plus 2 plus c. Okay. What 1/4 of c is still c, right? So I'm just going to add it like this instead of with the brackets. 1/4 of a constant is still a constant. That's all that big C stands for, is a constant. You don't have to get that specific on it. Okay? Did I lose anybody? That's the answer. What?
I get it.
That's one example.
Yeah.
Okay, so you're good. Okay, you get it. What we're doing is we're trying to make this nasty integration an easy integration by finding some easy substitution. Okay, now the substitution is the unknown. Like, honestly, you're going to be able to tell, you all, because you're smart, and you're going to say, wait, if I think ahead, and if I let this be my u, I'm going to have an x cubed in my derivative, which is also there. If that x cubed wasn't there, that would not be a good u for us. Okay? You can't create, you can manipulate constants, but you can't create variables and cosines and such. Go ahead.
So is the answer the word constant?
The answer is this.
Oh, okay. Or that.
No, that.
No, I meant. And so what's the thing happening to the side?
That's just saying that. That's why I didn't have to distribute my 1/4 is because the 1/4 of the constant is still constant, so I can just. Okay. All right. Let's try another one. This one isn't nearly as complex. So again, but we don't know how to do a square integration of a square root of something other than a square root of x. With square root of x, we do x to the 1/2, we do the inverse of the power rule, blah, 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 blah. Okay, so any suggestions about what you might be able to be? 2x plus 1 seems like a logical thing because that's the innermost of the function. Okay, so du dx equals 2. So du equals 2 dx, good. Okay, I don't have a 2. I have a dx that I'm going to switch out for the du, but I'm going to divide by 2 out. So I'm going to get the dx gets switched out. Okay, so let me be very clear about what I'm switching out. Dx is what? 1/2. I'm just going to go ahead and throw it out front because I know that's where it's going to go. And du is going to go at the end of the integration. Okay, so that's what I'm switching out with my u. I still have my square root, but now instead of 2x plus 1, I have u. Okay? Does that make sense? All right, go ahead and finish it. I'll give you a minute. Maybe. What do you got?
1/4 radical 2 x plus 1. No, the 4 is the radical's under. 1/4 radical 2x plus 1. We'll see.
If I think about the reverse derivative of this giving me this, that looks good. Let's rework it. Okay, so we did 1/2. This is u to the 1/2. So we did u to the, what's the antiderivative? 3 over 2 over 3 over 2, which is the same as 2/3, right? Plus c. I'm just going to throw the c out to these 2's cancel. U to the 3/2. Okay. Add, this is u to the 1/2, right? So add 1, divide by that number, right? I mean, I don't see a problem here. Did you not get that?
No, I didn't.
Okay. All right, plus c. So then that's probably going to be wrong, but we'll see. All right, 1/3. U now gets replaced. 2x plus 1 to the 3/2 plus c. That's done. The du right here. 1/2 du got replaced from dx. Okay. I feel like I need to cut that back. Come on.